Hello everyone. Today in this video we will discuss about impulse momentum equation. So first of all, what is meant by impulse and what is meant by momentum? So here the product of force and time is nothing but impulse, and the product of mass and velocity is nothing but momentum, and impulse is equal to change in the momentum is nothing but impulse momentum equation, and it is given as Ft is equal to m into v2 minus v1 or Ft is equal to m into v minus u in terms of the two velocities. Suppose for example in the question two velocities are there, then we have to use this equation or this equation in terms of the two velocities. Suppose for example in the problem any body is starting from the rest position, then initial velocity u value will be 0, then you will get the equation as Ft is equal to m into v final velocity. Suppose in the problem if any body is reaching to the rest position, then final velocity value will be 0, then you will get the equation as Ft is equal to m into initial velocity u value. So according to the problem, according to the given data, you will get the impulse momentum equation in terms of the two velocities, initial velocity and final velocity, or in terms of the initial velocity or in terms of the final velocity. And one more thing, impulse momentum equation is used to calculate the problems in the dynamics part, and units are Newton second. Now we will see some problems which are related to impulse momentum equation. Now here this is the first problem. Here a ball of mass 0.05 kg is dropped from a height of 12 meter on the floor and rebounces to a height of 7 meter. So here mass value is given as 0.05 kg, and here two height values are given. So we will take that two height values as h1 value and h2 value. So h1 is equal to 12 meters and h2 value is equal to 7 meters. And here two bits are there. So we need to calculate the impulse of a force and average force exerted by the floor on the ball, and taking a period of impact as 0.12 seconds. So time value is given as 0.12 seconds. So two height values are given and mass value and time value is given. Now according to these given data we need to calculate the impulse of a force and average force exerted by the floor. Now coming to the first bit, here impulse of a force is nothing but formula is F into T, but we don't know the F value. So we can use the formula in terms of the momentum as mass into change in the velocity, that is m into v2 minus v1. Now v values, velocity values are not given in the question, but we can calculate the velocity values from the height values by the known formula, that is v is equal to square root of 2gh. Now substitute h1 value in this formula, we will get the v1 value, and substitute h2 value in this formula, we will get the v2 value. So from h1 and h2 we can calculate v1 and v2 values in terms of meter per second. Now we know the momentum formula as mass into v2 minus v1. Now substitute all the calculated values and mass value in this formula. We will get the value as 1.353 Newton second. So this is the value for impulse of a force, that is nothing but a momentum value. Now in the second bit they are asking us to calculate the force value. So you can use the impulse momentum equation directly. Now from that equation make subject F value, then m into v2 minus v1, that we have already calculated in the first bit. So substitute the value from the first calculation. Next time value is given in the question, so substitute the time value. So you will get the force value as 11.276 Newton. Once again see the problem. This is the problem. Here mass value, two height values and time value are given in the question. So according to the height values we can calculate the velocity values. Next in the first bit, by using the momentum formula we can calculate the impulse of a force, and from the impulse momentum equation we can calculate the force value in this way. Now coming to the second problem, here a body of mass 175 kg is resting on a horizontal surface and is subjected to a horizontal force of 350 Newton. So here one force is acting along the horizontal direction and it is directing towards a positive x-axis. That is nothing but here according to the application of the force, here motion is towards the positive x direction. Next, here find time elapsed before block reaches a velocity of 15 meter per second. So it is reaching a 15 meter per second velocity. That is nothing but final velocity value is given as 15 meter per second. And here coefficient of friction value between the surface and the block is given as 0.2. Mu value is given as 0.2. So here coefficient of friction value is given is nothing but, here this problem will come under the friction topic. So according to the motion direction, you will get the frictional resistance force in the opposite direction of the application of the force. So here in this problem, according to the given data, here motion is directing towards the positive x direction. So here we know that motion and friction always opposes to each other. So according to the motion direction, you will get the frictional resistance force in this direction. That is nothing but it is directing towards the negative x axis. So here two forces are there which are acting along the horizontal axis on this body. So total force will be P minus FF force. Now according to the equilibrium conditions, we can calculate the FF force value. That is nothing but we know the formula for the frictional resistance force as mu r. Here mu value is given in the question. We can calculate the r value by using the second equilibrium condition, that is nothing but sigma v is equal to 0. Here weight value is given by the formula mg and mass value is given in the question, and we know the g value as 9.81. Now substituting the 9.81 and the mass value in the W formula, we will get the W value. And according to the equilibrium condition, second equilibrium condition, sigma v is equal to 0, we can say that positive vertical components is equal to negative vertical components. That is nothing but W value will be R value. Now substitute the R value in the frictional resistance force formula. Then you will get the FF value. Now we know the P value that is already given in the question. From the calculation part, we have calculated the FF value. Now from these two values, we can calculate the total force value which can be used in the impulse momentum equation. Now use the impulse momentum equation. That is nothing but Ft is equal to m into v2 minus v1 or m into v minus u or m into v or m into u. Now out of these all the values, we have to select m into v value, because in this question only one velocity value is there, that is nothing but final velocity. So here we have to use the m into v value. Now here in place of the F, you will get the two force values, that is P minus FF. So P minus FF into T is equal to m into v. Now we know the P value, we know the FF value, and mass value and velocity values are given in the question. Now make subject to T value. That value we need to calculate in this problem. So make subject to T value. Now substitute all the values and make subject to T value. So you will get the T value as 394.7 seconds. So this is our problem. Once again see the problem. This is the question given for you. Draw the free body diagram for this problem. Then according to the equilibrium conditions, according to the free body diagram, calculate the total force and substitute all the values in the impulse momentum equation and make subject to T value. You will get the T value in seconds. Now we will see one more problem here. Here a block weighing 19.6 kilonewton is pushed down a smooth inclined plane of slope 1/6 at a speed of 23.5 meter per second. So here weight value is given as 19.6 kilonewton. So convert into Newton by multiplying with 10 to the power of 3. And here okay, from weight value we can calculate the mass value. That is mass is equal to weight by 9.81. You will get the mass value in terms of kgs. Next here angle value, slope value is given. That is slope of 1 in 6. 1 in 6 is nothing but according to the slope calculation we know that sin alpha is equal to 1/6. And here speed value, velocity value is given as 23.5. So u value, initial velocity is given as 23.5 meter per second. Next the block comes to the rest position. So v value is equal to 0 by a braking force of 8 kilonewton. So here P value is given as 8 kilonewton. Next here again here they are asking us to calculate the time value only. So time required for the block to come to the rest. So here according to the impulse momentum equation, we can use the formula as Ft is equal to m into u. And here in place of the F, you will get two force values. According to the resolution part of the weight, you will get here W sin alpha, which is directing towards the negative x direction. That is nothing but here one force is moving in the upward direction, one more force is moving in the downward direction. So in place of the F, you will get two forces according to the sign convention. So here plus P minus W sin alpha into T is equal to m into u, and make subject to T value and substitute all the values from the problem. You will get the time value as 9.92 seconds. So this is our problem. Here coming to the rest means final velocity value will be 0, initial velocity value will be 23.5 meter per second. So according to the given data, we need to use the impulse momentum equation in terms of the initial velocity or final velocity, or in terms of the initial velocity as well as final velocity. So these are some problems which are related to impulse momentum equation in the dynamics part.